If that's the topic.
That's the topic.
Yeah. Okay. But as you can see, the topic has slightly changed in the last minute. So last week I stumbled across a video talk that was given by Matt Bergalis, one of the co-founders of the Meteor development group. And he was talking about Meteor 1.3 and what happens after that. Which direction are they trying to go? What are they trying to accomplish in the future? And I thought it was a good chance to put that in here as well. And especially since it kind of relates a little bit to the discussion that I want to originally have. Do we really need relational databases and Meteor applications? Or what kind of applications actually require us to use relational databases? And obviously also what is the actual difference between relational databases and NoSQL? Where do they differ and how does it affect my projects? So at first, Meteor 1.3, so this is I'll put that link on the website for the meetup as well. A few things that are new in 1.3, so they removed magic globals. And the main cause of that was that at some point, bigger projects, they just ran out of variable names. And it got very, very confusing. And the same reason why they actually introduced lazy loading as the default. So now, in the current Meteor 1.2, you can basically put all the JavaScript files into your source code repository and it will automatically load everything into the client. But you can imagine if you have like 200, 300 templates and a couple of libraries and 100 dependencies, your web app will become very, very large. And that means that the client has to download more. And from the beginning of Meteor, I think that was always a little bit of an issue where you have pages that users just visit once, just a blog or so. Meteor is not really suitable for that because you always have to download the entire back-end code as well, just to look at one article and read it and never come back to that website. So usually what we've seen was Meteor apps that are apps that you use every day that help you in your workflow and yeah, that kind of app. So another big improvement is ES 2015 is fully supported now, and this actually goes very, very deep and has a lot of interesting implications. So ES 2015 changed JavaScript quite a lot, and one of the major improvements was this new packaging system where you have modules and you have a very nice way to load modules, use them, and only load what you need. And that goes very nicely with the lazy loading, where now in 1.3 you will have to write a little bit more code because you have to write your import statements to import all the required templates or libraries. But it gives you also more control over the load order, and that's the interesting thing, it is also compatible with the standard of JavaScript, which makes it compatible with other technologies out there, but more to that over the next points. They additionally got heaps of questions all the time about, when do you do proper test integration? And I think we touched that earlier in the first talk about packages. So they're working on a better test integration, and primarily they're using Mocha, but he said in this talk they will support other testing frameworks as well, such as Cucumber or Jasmine or whatever is out there. And yeah, so that's going to help, especially for more serious projects, not your typical, just playing around a little bit, or POC. At the same time, they updated all the Cordova libraries to the latest, which brings a lot of really, really good improvements. So first of all, the WebKit got a little bit more performant, so it's a lot quicker now. And I think one of the major changes is that this wrapper, which was wrapping your Meteor application inside the phone, in the olden days that was JavaScript. And if you had a load error in your app and you're using hot code push, you could potentially destroy that app on the phone and have to reinstall it. And I think a year ago or so we heard a talk about, I think it was from Tom, about this package that he wrote, which kind of prevented these issues on mobile devices when you pushed corrupted code to the mobile device that it would automatically roll back. Now that's part of Cordova because they basically separated the wrapper of the application. They've written that natively in Java or Swift now, and the JavaScript app inside is loaded, and if it fails to load for some dependencies are not resolved or something else, you will simply end up with the Cordova wrapper will just roll back to a stable version and you won't have that problem anymore. So I said earlier that ES 2015 is a big change and it goes very, very deep, especially if you look at NPM, which in the latest version also goes down that road of basically packaging. The packages in NPM are now ES 2015, or they want to go there, that they support ES 2015 modules there, which basically means that it doesn't matter anymore if you have an Atmosphere package or an NPM package. You can use both in both technologies because they're pretty much the same. They all work on JavaScript. So NPM or Node.js developers, they can use Atmosphere packages. All the dependencies, they're just normal JavaScript modules. And the same goes the other way around. So in the past, we had to use wrapping packages for the standard libraries like Moment.js. There's a specific package on Atmosphere which just wraps the NPM module. And that's kind of not, that doesn't feel right. And in the future, we will be able to use the standard NPM modules a little bit more effectively. I mean, you can already do that. They improved that over the last 1 or 2 versions. I think since 1.0 or so, it was acceptable to use NPM packages, but it still always felt a little bit clunky, and sometimes you had dependency issues that simply couldn't be resolved. So the next section is they want to also improve the build tools because they realized larger apps actually took a lot longer to compile, and to a point where it got unacceptable. It just took too long, so they're going to improve that as well. Not sure about the details in this section. And the other big improvement is documentation. So I think everyone who already developed Meteor knows that the Meteor website, the development guide, is a very good source for information, and you usually find an answer there. And in the future, they want to even go further with that, where they want to show, hey, this is what we recommend in terms of practice. This is how you solve this problem. This is how you solve this problem. And they're also taking away a lot of community feedback and packages that are commonly used throughout the community. Just to name one, LD schema collection, which basically allows you to specify a schema for your Mongo collections. And that is used in a lot of projects. And what they're trying to do now is say, okay, if you want a schema, use this package, use it like this. So they want to introduce that part of the documentation into their own guide as well, which makes the Meteor website even more of a center of this one source which has kind of the information to everything you need. Then when he talked about front ends, I literally jumped up from the couch and raised my arms because he said, basically we're going to have support for 4 different front-end engines. So we have Blaze templates are still going to be supported. There was a big discussion about, is Blaze dead? And a lot of people said it is. And obviously React came in with 1.2 and they're going to continue integrating that better. And they're also going to support Angular 1 and 2 simply because it's a very widely distributed front end. A lot of people are familiar with it. And that's where Meteor says always like, we're going after the community. We're trying to look what is the community doing and bringing that into our product. And he said to justify why they're still supporting Blaze, he brought up a very, very interesting point, which I think I fully agree with. Every one of those frameworks has really, really good advantages, but they all have disadvantages as well. So, for instance, React and Angular, I think, have a bigger learning curve. With Blaze, it took me a day or so and could do almost anything with it because it's very simple. But also that limits the kind of use cases that are covered by it. And to be fair, if you have a small prototype application, Blaze will be the quickest way to get there. If you go via React, you have to define your components and you have a little bit more overhead in terms of describing those components. With Blaze, you don't have that. You just have a simple template, some helpers, some events, that's it. And so the nice thing that he mentioned is also that they're going to support those front-end frameworks in parallel. Very important because you can basically start as a POC, little prototype, you're just playing around a little bit on a weekend. You compile something and you say, hey, show it to someone, say, hey, I've got an idea, look at this. And then you're like, hey, that's a great idea, let's do a full-blown application. And suddenly you're thinking, oh God, it's going to be big and probably have about 30, 40, 50 different templates, going to be unmanageable with Blaze. You can seamlessly switch from Blaze to React and basically just create your new templates or new components in React and still keep the Blaze templates fully functioning. So you can run those different technologies in parallel, which is, I would recommend only to do that in a transition phase, because otherwise it becomes a bit chaotic at the end of the project. Yeah, and the other thing that they tried to address was data. One thing they realized is that this kind of reactivity that Meteor gives you, that we all know and love, that this is kind of something that is very, very special and should be available to a wider audience. Right now, you kind of have to develop Meteor. There's not really a plug-and-play solution out there which you can use in any technology, and that's what they're trying to do with the Apollo data stack. And I'll get to a few of the details in a little bit. But first, looking at a little bit of Meteor database history. So obviously we have MongoDB built in, which sometimes is an issue because you can already see that if you're using it as an enterprise application, MongoDB is actually not fully free to use in an enterprise environment, which basically means, yeah, you can start developing, but then you eventually still have to pay for the license. And also it's a document store, which, I mean, when I started with Meteor, that was actually the first NoSQL database that I was using. And yeah, it takes you a while to kind of see the differences and figure out how to use that new technology. But a lot of people actually ask, well, can you still have SQL? I mean, I'm used to SQL. I've been developing SQL all my life. I've been doing it for 10 years. And now I have to do document-based storage. Why? Just give me SQL. So they started looking into PostgreSQL because they offer a cursor technology which allows you to monitor a data set and get this kind of reactivity. The same thing is solved in MongoDB by Oblog. So in Meteor 1.3, well, it's 1.3 and beyond, so that's work in progress. And so this is just what they have in mind right now. Basically what they have a single Apollo API, which is just how you access your data. It is irrelevant how you store your data. That's handled by probably some configuration in the background. Underneath the API, they have this GraphQL cache, which basically produces your responses. And then you can connect that with any backend that you can think of. So you can have SQL backends, you can have RESTful backends, you can have DDP connections or NoSQL databases. And if any of those don't offer you reactiveness, like some cursor technology or something like REST interfaces especially, they will pull on a regular interval which you can configure, which is then fed into this GraphQL cache, which offers you the reactiveness which is pushed through to the API. So that's definitely something to look forward to, and that will sort of solve the need for PostgreSQL because you can basically plug it in here then at the end. But as I said, it's not there yet. But what I've seen is that the development of this Postgres driver has kind of stalled. Not much happened. The Git repository is quiet. There's not many discussions about it. And I think it was a few months ago when I heard that a few of the core developers actually left the project. And I think with the Apollo stack coming, and I think even if they just, get some sort of beta out there, they will have some SQL backend which you can use, and you can then. And the idea is that they then offer this Apollo stack as a ES 2015 package module, which basically can be used anywhere. So you don't have to program Meteor to use Apollo. Standard node developers will be able to use it as well because it's just a standard package. So that's one of the key benefits of Meteor moving towards this more generalized technology. What I want to do next is kind of look a little bit into relational databases versus NoSQL. And so this is kind of a little bit opinionated, I agree. And also just want to give a rough overview. So basically, relational database, we know it's always structured data. You have usually a table description which says, okay, this column, this type, and then you have your key definitions, foreign keys, and all that stuff. So it's fully structured, where NoSQL databases usually are semi-structured. Now, what does semi-structured mean? It's basically, when people talk about not structured, they usually refer to data lakes, which is something that only exists as an idea. It hasn't been implemented yet, where you just store unstructured data. But how do you query unstructured data? So you always need some sort of structure. In MongoDB, we have collections, for instance, and then we have fixed fields like the ID field. In CouchDB, you would have a revision field for the document and an attachment field which contains the attachment metadata. So that means semi-structured. There is still some sort of arrangement, and the format of the entries is usually defined as well. In our case, it's JSON. And so that is the main difference here. And also relational databases, as they say, store their data in relations, which basically means you would usually have one big domain object, a person, and you would have one table which only contains some base properties about it, and the rest, like, okay, my friends would be a separate database table which have foreign keys to other tables and all that stuff, which basically means you split up this object, person, with all its relations into separate tables. Now that makes it very nice, easily to manage them as kind of entities, a relation itself, a friendship, for instance. But it also doesn't help really to have a general overview. Okay, what is this person actually looking like? I have to make a very, very complex query or multiple queries to get all the information in one place, which means you will have some performance issues here, where NoSQL databases usually work object-oriented, which is how REST endpoints usually work. You get an item with a specific identifier or a list of items. And they're usually not just the little corpus, the base of the object, but it contains the relations as a JSON payload attached to this object. So one of the key features, however, of relational databases is the consistency, or in more general, the ACID compliance. And it basically means that because you have foreign keys, you can reference, say, you have one record here and it references another record here. Now you want to delete this record here. The database will actually prevent you from doing so because it realizes, hey, this document, I can't delete it because it's still referenced. And that is very, very important for a lot of applications that work in the area where there's legal obligations to keep records of everything, financial institutions, insurance companies, anywhere where you have transaction data like online shops, because you need to be able to always have all the data, because just losing one record might be a catastrophe which might cost you millions. And on the other side, where NoSQL can be a little bit quicker than relational database, simply because it usually doesn't care about that. If you think about relations between different documents in MongoDB, usually what you end up with for an one-to-n relationship is you just have a field with an array of strings, and each string represents a document ID which one you reference. Now you can remove those target documents. That object that holds the reference doesn't care. The database doesn't care, because there's no logic that checks or that even connects those data points. Your application does that. Your application sees that list of IDs and says, yep, this is that object, this is that object, and this is that. And but on the other hand, you also have a lot of additional functionality in NoSQL databases. Now, MongoDB probably doesn't give you too much extra functionality, but I've been working with CouchDB for quite a bit now, and there's a lot of really, really interesting stuff there. So MapReduce, probably a bit abstract, and it took me a while to actually figure out problems that it actually can be applied to nicely, or which are kind of the nature, what is the nature of the problem that is perfect for MapReduce. And but there's other stuff like, as I mentioned before, CouchDB has attachment handling, which in MongoDB is always a bit cumbersome because you have this base 64 encoded string, because, well, MongoDB can only do one thing, JSON. It can do that very well, but only that. And so another reason I think why people are still asking for relational database support in Meteor is simply because, well, that's what they know, that's what they've been working with. When I first started working with Meteor, my first question was, do they have MySQL as well? Because, well, that's what I was doing, and that's what I knew. And also, you have to consider that those MySQL or Oracle databases or MS SQL Server or DB2, they've been around for donkey years, for decades. So they've matured over time, and they basically offer you all the functionality. Everything is sort of stable. There's only very few bugs in there, and it's all optimized and well documented. You won't find a single code snippet that is not at some point documented somewhere. So that kind of makes it very easy for newcomers to kind of get started with it, where with MongoDB you still have to go through that initial learning curve, and then you start with another database and you have to start from scratch pretty much, because they have completely different query language, completely different way of structuring their data or storing the data or even accessing it or managing it. And but as I said, the thing is that NoSQL databases, I think, have the potential of being a lot more efficient for solving specific problems, because there's there's the same amount of problems out there as there are database solutions for those problems or for subsets of those problems. And I think that's where it's kind of the engineer's role to decide, hey, I've got this problem, which database do I pick? And of course, there's several considerations like licensing costs, learning curves, have I worked with it, do I have resources, what drivers are available, and all those sort of discussions are important for that. And to just put it into a little bit of perspective, this is not based on any data. This is just something that I drew. So, but it is basically just showing that. So basically, okay, let me quickly explain how I came to that. So I was watching a couple of talks that were talking about big data and relational databases and NoSQL databases, and I found one where they tried to define big data, and I found that very, very interesting, because big data is usually just a buzzword that managers throw around to sound interesting. And at the end of the day, there was this architect who gave this talk, and basically what he said was, big data, that's where even a sharded relational database with, I don't know, 200 nodes just collapses under the workloads. And we're not talking about a gigabyte of data here. Any relational database can handle that. We're talking about tera and petabytes here. And so basically, this graph shows that NoSQL databases tend to have a fairly linear scalability. They actually, I read an article the other day, I can't remember if it was HBase or Hive. I think it was Hive, where they achieved, over I think 200 or 400 nodes, they achieved linear scalability. So I think usually us lot will probably work in this area, where it doesn't really matter. But it has to be considered if your project eventually grows and you might have more data, and especially for analytics application, because they usually deal with a lot of data. And then I found something else very interesting. So I was actually looking around not too long, so I just found this. It was a DB engine range, and basically what they're doing is they give each database a score, and that's basically a combination of the amount of job offerings that require specific knowledge with a specific database technology. So you have a lot of job offerings that require you're an Oracle certified database administrator. And then there's also social networking activity, like using Twitter feeds, I think, for that. And they also search Google and Bing for each database name, and then look how many results are coming up. So this is kind of how the score is calculated. And obviously, in the relational databases, the three big ones on top, Oracle, MySQL, MS SQL Server, and MySQL, been around for donkey years. You find heaps of documentation. Everyone has sort of used it at some point in their history, probably. And so that's why they're that high up. And that's the thing, they're mature. There's a lot of heaps of documentation out there, and that's why they are so popular. But in general, what you see here is that this is 2013, this is 2016. It's kind of like not really improving much. There's only a few, like SAP HANA, which kind of are trending, which get a little bit more attention these days. Now, and that's 17 out of the top 32. Now, NoSQL is obviously only 15 out of 32, but in general, what we can see is a trend that goes more towards the top. So most of the databases are actually trending, which means there's a lot of interest these days in that, because there's a lot of applications where people just think, well, I'm kind of sick and tired of paying big license costs to this and that company, why can't I just use something open source? Okay, well, it's NoSQL, who cares? My problem doesn't require asset compliance, So let's do that. And I think that's why those are trending. But obviously you can see, I mean, the most popular one right now is Mongo, which sits at a score of 200, where the big ones in the relational are sitting at over 1,000. So there's still a difference. And I mean, the market share of relational databases is probably still higher than NoSQL. So on this last slide, what I'd like to do is kind of just put a couple of buzzwords and things that you think about usually when you're working with NoSQL and relational databases, and try to get a little bit into what kind of constraints does each of those things put onto your storage, and what kind of applications are suitable for that. So in the relational database world, usually you begin with just finding your schema. So you create your tables, you create your columns, you create primary keys, foreign keys, and all that sort of stuff. And if you look back, say, 10, 15 years, usually software development projects were done using the waterfall approach, which means at the beginning, you write your 500-page requirement document, which included the data structure. And usually there wasn't much change to that data structure after you initially created that document, which meant relational databases will find that context where you define it at the beginning in the requirement document, and this you just employ a database admin who actually implements it. And in today's world, we have agile practices, which kind of usually start out with data model. We haven't really thought about that. Let's start with this. And then as you go, you kind of throw away objects, you add new fields, you rename fields, you split them up, and you kind of reorganize everything. And so if you do that in SQL, due to the data model, you will have a lot of extra effort manipulating and kind of keeping that consistent with your application's data model. On the other hand, you have end-to-end tables, which are very, very nice, especially to inspect relations. And that's definitely one of the major benefits of relational databases. Although it has to be said that even in the NoSQL area, there's some things that can do even that better. And they're called graph databases, which basically are a representation of nodes, and those nodes have edges to other things. And that's kind of the same as an end-to-end relationship, basically. And one big advantage of relational databases, which I kind of miss these days, especially in Mongo, is the fact that in SQL you kind of had really good support for SQL scripts, so batch scripts, for loops. You could do data migrations so easily. These days, I do it in the application and not on the database level, which means, well, my application actually is a little bit polluted with data migration code, which normally I can just keep in a database. And so that's definitely something that I sort of miss from NoSQL. So the different granularity in NoSQL, basically having objects stored, I think that is something immensely useful, and also part of the reason why especially document-based databases are so quick and so useful for web applications. Because, I mean, looking back a couple of years, there was like SOAP was kind of the newest thing in the Java world, and everyone is doing XML. And everyone who looked at an XML document knows it's very hard to read. There's a lot of meta information. Your document, your payload just becomes immense. And someone thought, hey, actually, why not use JSON? It's much smaller. And that's when REST came. And these days, you won't find many SOAP interfaces or SOAP web services anymore, but most is actually done with REST, which is JSON, which is the same as MongoDB or CouchDB handle. So if I have a relational databases, I usually have tabular data, CSV. Now I have to transform that tabular data into my JSON object, enrich it with a couple of other queries to retrieve all the relations. That just spoils the performance, and I think that's where, even with smaller data sets, NoSQL will always be quicker. Another thing, obviously, you have those nice functions like fuse and MapReduce, which give you ways to query data, analyze data. Now, SQL has the language supports that as well. You can do aggregation and all that sort of stuff. But NoSQL databases usually are made for that specific purpose, which means they do it more efficiently, and they have a better integration, and it's kind of relatively easy to write a MapReduce function, actually, compared with a complex SQL script, which sort of would do the same thing. And that's why I said it's kind of problem-oriented. So for every problem, there's a matching database solution. Now on the RDBMS side, I mentioned it before, you have financial data and transactions which kind of force you to be asset compliant, and you will end up with an RDBMS. And at this point, the question is just, well, do I use the RDBMS for the rest of my data as well, or do I only use it for that data that is sensitive that I have to maintain there? But obviously, you don't want to have two separate database connections in the same app, so that's always a bit of a trade-off, and I think it depends a little bit on the amount of data, the structure of the data, and the size of your application, obviously, or the importance, the impact. And of course, as I said before, the licensing cost. I mean, MongoDB also has a licensing model, but the rest of the NoSQL database, you can use most of them out of the box for any purpose, and a lot of them are actually open source as well, which makes it a lot easier and cannot be found as that in the relational world, where you have your big manufacturers that just say, well, corporate product, no source code is released, you can't even inspect it. And so that brings me to kind of my conclusion for choosing NoSQL over. I'm not saying that there's no need for relational databases anymore, but from my experience, what I experienced over the last year, there wasn't a single problem that I couldn't solve with a NoSQL database, or actually couldn't solve better with a relational database. And primarily that's convenience. Speaking about the, you don't have to do manipulations for REST interfaces. I'm building a couple of web services, and all I do is just, my web service code is pretty much just a proxy for the database. So a request comes in, give me that document. Here it is. I don't have to do anything. I let the database do everything. And the fact that my data structure is not fixed also reduces the cost of development. Because if I have to maintain the data model and the SQL data structure all the time, or even migrate my data expense, that just increases the cost of development. So it gives me a lot more flexibility, especially in those early stages of the project. And of course, scalability, although that only becomes really important if you go past the terabyte marker, I think. So yeah, so that is my go at this topic. Any questions?
Yeah. Can you expand on the GraphQL? If it is a middleware that they work in?
Yeah, so I don't know exactly. I haven't looked into it in detail, but what I understand, it's the middleware, yeah. So you basically have the API, that's your communication endpoint, and underneath, the GraphQL cache kind of keeps the data, but independent from the underlying storage solution. So it doesn't matter if you store it in tables, if you store it in documents, or even just as binary in some file system. It doesn't matter anymore, because the GraphQL cache source, it's magic happening there. And they haven't done it yet. So we have to wait a little bit to see where this is going.
Sorry, so GraphQL is something that already exists and they're trying to blend it with...
Yeah, exactly. That's the idea.
Facebook technology, isn't it? Yeah, is it like a way of querying where you sort of define the schema at the same time as you do?
Honestly, I haven't looked deeper into it. I just looked at the facts and how it's supposed to work together, and that was kind of enough information for now.
Yeah.
A while ago, I read that when MongoDB saves queries, it doesn't, like when a lot of concurrent saving queries, it doesn't save right to the database, but it does the visual saving, and sometimes it misses that. Is that problem fixed, or is
I wouldn't think so. And that's so if you look at performance graph, another reason why those NoSQL databases are usually tend to be quicker than relational databases is because they're optimistic. So yeah, you might lose records, but that's kind of the reason why they're so much quicker. If they would make sure that every single item is referenced and all that sort of stuff, it would just be the same as relational databases. So that's what I'm saying. If that is important to your application, you cannot lose a record. It would cost you a lot of legal trouble. You might even go to prison for that. Then you have to use RDBMS instead.
So, do they have any solution to solve that problem? Or any, do they propose any way of solving?
Oh, look, I think especially when you have this issue where, say, you want to delete an object, and but you still have a reference to that object, right? You don't detect at the moment you delete it. Say occasionally you could run consistency checks as a background application, obviously, not within the database. And it just goes through the data and figures out, are there any inconsistencies? If there are inconsistencies, well, either try to fix it automatically or send an email to the system administrator informing him, hey, someone deleted a record here, I couldn't find that reference. And then you might go back into the access logs and try to figure out which query deleted the record and maybe reconstruct it from an older backup or so. So there are solutions out there, but you really don't want to go through that. So usually when you can't afford to lose records, you would use something that gives you the guarantee that all your data is persistent and consistent.
One thing with GraphQL that I thought was pretty good is that the big limiting thing with Meteor has obviously been that database selection. So the big factor around that is going to be database triggers, which is not really available to a lot. You know? So with GraphQL, as it's shifting that towards the application, so when you write to a table, it's going to keep track of that, from what I understand.
So the question basically is the effort in the application or is the effort in that GraphQL some schema or some sort of meta description, which you're basically talking about the mapping between the underlying storage structure and how you feed that into your GraphQL cache.
Yeah. So
and
instead
then,
of polling,
yeah,
we're shifting it.
I would think that it's both. Oh, hang on. No, actually, I would think it's only in the Apollo stack. Because basically, it doesn't offer you directly, I think it doesn't offer you directly a GraphQL interface, but it has this API on top, which handles your request in a uniform way. It's the same syntax. And how it determines what you really want to do or what data you are trying to retrieve, that depends on the internal definition, which kind of depends a little bit on the underlying structure.
So that's probably going to be like a secondary sort of service.
No, I wouldn't know, and I think that's the thing. So please keep in mind, it hasn't been implemented right now. Right now, they have a few ideas, and I think they have a few components here and there. And the overall goal is to give this reactivity to a wider audience, supporting multiple different backends. And I mean, anyone who's already developed or who used external web services will have faced that issue where you pull the results once, you keep them in your template. Well, when do you upgrade? When do you update them, or how do you refresh them? So that's kind of the problems that this data stack is trying to resolve.
Just a comment for those interested in development of Apollo and especially GraphQL. There is a preliminary design already out there. So just go into the GitHub, look for the Meteor Data, I think it is, the repository, and from there you can follow discussions, you can follow the design documents, and everything that explain a lot of what has been asked here.
And that's actually a very good point, and I almost forgot about that. So in the video, in the talk that Matt gave, he also mentioned that they're trying to reconsolidate the current GitHub repository, which is just a huge list of packages. It's just very hard to find what you're actually looking for. And what they're trying to do is kind of split them up, so all the account packages go into one sub-repository, and they kind of try to also manage them a little bit more independently. So you have people that are responsible for all the accounts package. If you're looking for that, you go there. It makes it easier to collaborate. It makes it easier to find your project. Easier for them to organize the, by now, huge amount of packages. I mean, I guess when they started a few years ago, they just had about 5, but now it is more like 500, and that's hard to manage. Yeah.
One thing I trouble with using MongoDB is duplicates. So my example was I had an application. I have a user which can link to places, and the places can link back to users.
Mm-hmm.
So I end up replicating my references.
Like my application. That's the end-to-end relationship. Yeah.
My user reference to it. So you just
yeah, that's how you do it exactly. So your objects are independent from each other, and the only reference, the only evidence of that end-to-end relationship between your place and a set of users, or one user and a set of places, is basically this kind of field which holds all the IDs of the other objects that it is related to. And it will require, so that's the thing, not having the asset compliance and that kind of relational model, it will shift the responsibility to you as a developer to make sure your data is consistent. And that's the danger when you're thinking financial data or insurance data or stuff like that. Because, well, you can't really rely on every developer being as careful with the data as yourself or as you should be. And eventually you will end up with some developer who just said, oh, I don't like this item here, I'll just delete it. And, well, if you don't check in your app, then you cause trouble. So, yeah. But the database just gives you a little bit of a guarantee for that.
Yeah, but even if you scale large, you want to just duplicate all your references.
Yeah, usually they're just 16 characters and numbers. Well, it's not massive. So it depends. Look, it really depends. If you have an application that is primarily composed of those relations, well, don't use Mongo. Use a graph database or use a relational database. If you just how you describe this problem, if this is your main interaction between people and places, then obviously MongoDB is not really great, especially if, say, this list of references can get enormous. So in that case, you're better off with a different database, obviously. So it always depends on you as the engineer to figure out what's the best way of storing my domain objects in some persistent storage, and how do I kind of what kind of management operations do I have on them? If I just read, it's the same in SQL databases. If you do mostly reads, MySQL is very, very good, even for huge amounts of data, but it's very slow writing. So if you have an application that does a lot of transactions, MySQL is not ideal. You're better off with Postgres. But for instance, OpenStreetMap runs exclusively on MySQL. Because, well, really, they have a bunch of nodes there. I think it's 20, 40 nodes or so. But it's so quick to read that you get really, really good performance. So it depends on the problem. Then thank you for listening.